Does it ever seem like you have all the data you need, just never in the same place? Sensor data, ERP systems, production metrics, they're all scattered across siloed platforms. It slows everything down. Decisions, insights, performance. The solution? A unified namespace, a single real-time source of truth for operations. And MongoDB is the perfect technology to power it. A unified namespace, UNS, is a centralized structured data environment that serves as the single source of truth for real-time data across all systems and devices in an enterprise. Instead of relying on the traditional automation pyramid with data flows up and down between the layers, the UNS establishes a single flattened layer where all manufacturing data is published and consumed. It integrates and organizes information from disparate sources such as sensors, machines, and enterprise software into a consistent naming hierarchy, enabling seamless data sharing and system interoperability. Think of it like this. The ERP posts a work order, MES reads it instantly and is able to create a job while the shop floor updates progress live and the system views the production line availability. Everyone's using the same live data from one shared source of truth. No duplication, no delay. The catch? You need a reliable database that can handle constant change. Machines evolve, sensors get added, data formats shift. The platform can't pause production or rebuild integrations every time something changes. That's why flexibility is key. MongoDB is the perfect fit for this. Instead of rigid schemas, MongoDB stores data in a flexible JSON-like documents. When an adapted work order, job, or machine's vibration or temperature in a new data format is added, MongoDB adapts instantly without needing a schema redesign. It supports real-time data ingestion with tools such as Kafka, CDC connectors, and MQTT broker. In change streams, MongoDB can capture live data from the ERP, MES, and shop floor systems as it happens. You can monitor live sensor output, track work orders and jobs progress, production lines, status, and machine details, and send all of these data to dashboards, correlate product cost with machine efficiency by showcasing not okay items into the actual final cost out of a single database. So how does this work in practice? Let's look at our Leafy factory demo.
Here's how it works. We will create a new work order in the Enterprise Resource Planning System Simulator through the form. Firstly, we have to choose the product to generate, in this case, a gear housing with our desired item's output quantity. The planned start and end dates can be modified within the given values we want to select. When the work order is submitted, it will be shown under Created Status. By clicking in the curly braces icon, we'll be able to visualize in the sidebar the latest document models, which highlights the selected work order snippet tail. Once created, the work order will be able now to submit a job in the Manufacturing Execution System Simulator by selecting from the IDs of the available work orders as well as the production line of our choice. Each production line has predefined machines that, depending on their status's availability, will be able to send our job on the line or the other. With our job now being created, we can see how the document model now shows the array of jobs with creation date, status, and target output. The no-code products and quality rate will be populated from the data generated once the job is completed. In the shop floor simulator, each machine has its own card with status, telemetry, last maintenance, and current job. Inside the values form, the temperature and vibration can be modified at will per machine. Selecting the values above the thresholds will directly impact in our current job OK and no OK units production. By clicking on the curly braces, we can visualize the factory collections document model, retrieving the latest values. Additionally, by clicking in the Start Shop Floor Simulator button and Time Series tab, we can select our desired machine, retrieve relevant metadata, and telemetry below. The chart indicates the mean machine's temperatures, which can be updated with the Refresh Chart button, or wait for the automatic hourly update. The machine's status will go back to available when the job is completed, while the quality rate and no OK units will retrieve the values from that last job. As for the work order, it will also be marked as completed and showcasing the actual cost, which will either increase or be maintained from the planned cost depending on the amount of no-OK units produced.
In the demo, we simulate a manufacturing environment where data from ERP, MES, and shop floor systems are connected via MongoDB. Here's how it works. ERP and MES data is stored in SQL. We use Debezium connector to capture database changes and publish them to Kafka. The MongoDB Kafka Sync connector pulls that data into MongoDB, live and structured. Simultaneously, MQTT streams send live shop floor data like temperature, machine status, and quality readings into the system. All of this data flows into one centralized MongoDB cluster. We also enrich each data point with key metadata like machine ID, operator, shift, and location, using the ISA 95 model. This creates a real-time searchable view of operations with synchronized updates across systems. Whether a work order is updated in ERP or sensor data changes on the floor, it's reflected across all views instantly. Alongside time series collection, these data can easily be queried together. A unified namespace breaks down data silos, enables faster decision-making, and aligns operations with business goals, all powered by real-time contextual data. MongoDB is the perfect engine for that foundation. With its flexible document model, real-time streaming, and cloud-native scalability, MongoDB doesn't just store data, it powers the future of smart factories. Want to see more? Check out our solution guide and our GitHub repo for a hands-on walkthrough. Thank you so much for watching.